In this video, we are going to discuss measures of location. Quartiles are numbers that separate the data into quarters. Quartiles may or may not be part of the data. So to find the quartiles, the first thing we're going to do is find the second quartile, which is also the median or the 50th percentile. And the way we're going to do that is we are going to count. So we have 14 pieces of data. So the middle of that, 1, 2, 3, 4, 5, 6, 7, is right here between 6.8 and 7.2. And so all we have to do is find the middle of that, which is 7. So our Q2 is 7. Once we have that, we can find the first quarter. So I'm actually going to draw a line down there. So that's our Q2. Q1 is going to be the middle of these. So Q1 is going to be 2, this number here. Q3 is going to be 9. So now that we have Q1, Q2, and Q3, let's take a look at what this means. It means that 25% of the data rests below Q1. Between Q1 and Q2 is another 25% of the data. Between Q2, Q3, 25% of the data, and between Q3 and above, 25% of the data. Next, let's talk about the interquartile range. So the interquartile range is a number that indicates the spread of the middle half or the middle 50% of the data. It's the difference between Q3 and Q1. So the IQR can help to determine potential outliers. And a value is suspected to be a potential outlier if it is less than 1.5 times the IQR below the first quartile, or more than 1.5 times IQR above the third quartile. So potential outliers always require further investigation. All right, I just cleared out the calculator, but it also cleared out all the notes. The last thing I want to say about the IQR is that a potential outlier is something that's significantly different from the other pieces of data. It could be an error, it could be a data entry error, or some other kind of abnormality, and they can be extremely important in understanding the data. They can also indicate that you need to go back and double check the values that you've entered. Let's talk about percentiles. Sometimes we'll have a problem, just like this one, where they'll want us to find certain percentiles of the data. So in this example, 50 statistics students were asked how much sleep they get per school night, rounded to the nearest hour. Here are the results. We need to find the 28th percentile, find the median, find Q3 and the 75th percentile. So we'll start with finding the 28th percentile. We're going to notice that in the cumulative relative frequency chart over here, 28% of 50 data values is 14 values. There are 14 values less than the 28th percentile. So here's the 28th percentile right here. They include the 2 4s and the 5 5s and the 7 6s. So the 28th percentile is between the last 6th and the first 7. So the 28th percentile is 6.5, right between there. So 6.5. Now to find the median, we're going to look again at the cumulative relative frequency column and find 0.52. So the median is the 50th, right here, is the 50th percentile or the second quartile. So 50% of 50 is 25. There are 25 values less than the median. They include the 2 4s, the 5 5s, the 7 6s, and 11 of the 7s. So the median, or the 50th percentile, is between the 25th, or 7, and 26th, or 7 values. So the median is 7. The third quartile is the same as the 75th percentile, so you can eyeball this answer If you look at the cumulative relative frequency column, you find 0.52 and 0.8 right here. When you have all the 4s, 5s, 6s, and 7s, you have 52% of the data. When you include all the 8s, you have the 80% of the data. So the 75th percentile has to be one of the 8s. You can check this answer by counting the values. So this is the same, 8 and 8, because those are exactly the same. Now let's take a look at how to find the kth percentile. So if a problem says, what's the 12th percentile, or the 50th, or the 70th, this is going to show you how to find that. So there's a formula, and the one we're going to use is this value here, where K is the kth percentile that we're looking for, I is the index, and that's the ranking or position of the data value, N is the total number of data. So the first thing you have to do is order the numbers from smallest to largest. Then we are going to use this equation here. If I is an integer, then the kth percentile is the data value in the ith position in the ordered set of data. If I is not an integer, then we're going to round up and round down to the nearest integers. Then we have to average the two data values in those two positions in the ordered data set. This is easier to understand in the example on the next page. So let's take a look at an example. Listed are 29 ages for Academy Award-winning Best Actors in order from smallest to largest. So A wants us to find the 70th percentile, and B find the 83rd percentile. So we'll start with the first one. So our K value is 70, I is the index, and we'll figure that out, N is 29. So we are looking to replace what we know here. So we are looking for the 70th percentile, so 70 over 100 times 29 plus 1 equals 21. So 21 is an integer, so the data value in the 21st position is 64, and we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21. So 64. So the 70th percentile is 64 years. Now let's take a look at B. We're going to do the same exact thing. 83 divided by 100 times 29 plus 1 equals 24.9. So 24.9 is not an integer. So what we have to do is we have to round it down to 24 and up to 25. So the age in the 24th position is 71. The age in the 25th position is 72, and then we average those two numbers, and the 83rd percentile is 71.5 years.